Hook. You've been using grep for decades. Or maybe just a few years. Either way, you've hit this wall. You search your logs for error. But the bug was logged as failure. Or crash. Or unexpected shutdown. Grep finds nothing. You miss it. The incident goes uninvestigated. That wall has existed for 50 years. Since grep was written in 1974. Half a century of the same limitation. A developer just knocked a hole in it. With Rust and word embeddings. The tool is called ngrep. And it changes what search on the command line even means. Let's get into it. Section 1, what it actually does. Ngrep is grep, but it searches by meaning, not just by exact characters. Here's the practical difference. You run ngrep on a log file, searching for error. Regular grep would find lines containing the literal string error. Ngrep finds those too. But it also surfaces lines containing failure, crash, exception, fault, problem, because those words are semantically close to error in vector space. It uses word embeddings under the hood. That means words are converted into numerical vectors, lists of hundreds of numbers that encode meaning. Words with similar meanings land close together in that space. Dog is near puppy. Error is near crash. Ngrep measures the distance between your query and every word it encounters, and surfaces matches above a threshold you control. The tool is written in Rust, which matters for two reasons. First, it's fast. Rust gives you near-C performance with memory safety. Second, the binary is self-contained. No Python environment to set up. No pip install. No dependency hell. You download it, you run it. The command line interface mirrors grep intentionally. If you know grep, you know ngrep. You point it at a file or pipe text into it, pass your query, and get ranked results back. What surprised me was how tight the matches actually are in practice. This isn't a fuzzy, anything-goes search. The embeddings are trained on real language data. When you search for fast, you get results for quick, rapid, swift, not random noise. The semantic field is coherent. And because it ranks results by similarity score, you can see exactly how confident the match is. That transparency is something grep never gave you. Grep is binary, match or no match. Ngrep gives you a gradient. Section 2, what it does not do. But here's the thing, ngrep is not a drop-in replacement for grep. Not even close, for most use cases. Speed is the first honest limitation. Grep is absurdly fast. It's optimized over 50 years to scan gigabytes of text in seconds. Ngrep has to compute embedding similarity for every token it encounters. On large files or long pipelines, that cost adds up. This is not the tool you reach for when you need to scan a 10 GB log archive at 3 a.m. during an incident. Second, it works at the word level, not the line level, by default. Grep thinks in lines. Ngrep thinks in tokens. This changes how you interact with output, and it takes some adjustment. Third, the embeddings it ships with are general purpose. They don't know your domain. If you work in genomics and search for expression, you might get results about language or emotion, not gene expression. Domain-specific language is a real gap. Fourth, it doesn't support regular expressions. regex is one of grep's superpowers. Pattern matching, capture groups, lookaheads, none of that is here. For structured log parsing or complex pattern matching, grep wins. And fifth, and this is important for anyone considering it in a pipeline, the output format isn't guaranteed stable yet. This is a young project. APIs change. If you're scripting around it, build in some tolerance for that. This tool is not trying to win the general-purpose search race. It's solving a specific, underserved problem. Section 3, what it could realistically do in the future. So where does this go from here? Let's stay grounded, no fantasy roadmaps. The most realistic near-term improvement is swappable embedding models. Right now you get one set of vectors. If the project allowed you to plug in domain-specific embeddings, medical, legal, security, code, the tool becomes dramatically more useful in specialized contexts. That's a concrete, achievable feature. Second, a similarity threshold flag in the CLI, if it isn't already configurable, would let users tune precision versus recall. More control, same concept. Third, integration with tools like grep or FD, the modern Unix toolkit, would make ngrep feel native to how developers actually work today. A plugin or wrapper layer could get there without a full rewrite. And longer term, if someone built IDE integrations, think VS Code or NeoVim, semantic search over a codebase becomes something you could do without spinning up a full RAG pipeline or a vector database. That's a real workflow win for solo developers who can't justify the infrastructure overhead. The foundation is solid. Rust means performance ceiling is high. Embeddings are a well-understood technology. The primitives are right. Section 4, Why it exists. So why build this at all? What's the actual problem? Grep is a perfect tool for exact matching. It does that one thing extraordinarily well. But language isn't exact. Humans write the same concept a dozen different ways. Log files aren't written by the same person, with the same vocabulary, on the same day. Documentation drifts. Code comments are inconsistent. The gap between what you search for and what you actually need to find has been papered over with experience and intuition. Senior engineers know to also search for exception when they search for error. Junior engineers miss things. Everyone misses things when they're tired. Ngrep is an attempt to close that gap at the tool level, not the human level. Instead of requiring the user to know every synonym, you let the model carry that weight. This is also a signal about where command-line tooling is going. We're starting to see a generation of Unix tools that don't replace their predecessors, they augment them. Tools that add a layer of semantic understanding on top of the fast, reliable, battle-tested primitives we already have. Ngrep isn't trying to replace grep. It's trying to handle the cases where grep was never enough to begin with. If you work with logs, documentation, or any unstructured text, this is worth 10 minutes of your time to try. Next episode, we're looking at a tool that runs local LLMs directly in your terminal, no API key, no cloud, no latency. Same honest breakdown. Hit subscribe so you don't miss it.